Ever looked at your car and wondered what's really going on under that shiny metal skin? It's not just a machine, it's a moving science experiment. A symphony of engineering that gets you from point A to point B. And today, we're going to pull back the curtain and explain it all, simply. Let's start with the heart of most cars, the internal combustion engine. Imagine a tiny, controlled explosion happening thousands of times per minute. That's basically it. Your engine mixes a tiny bit of fuel with air inside a cylinder. A spark plug ignites it, and boom, the explosion pushes a piston down. This up and down motion is converted into rotary motion by a crankshaft, and that's the power that eventually turns your wheels. It's a four-step dance. Suck, squeeze, bang, blow. Intake, compression, power, exhaust. That's the magic. But what if you want more power without a bigger engine? Say hello to the turbocharger. A turbo is like a tiny windmill, or turbine, that uses your car's hot exhaust gases to spin. This spinning turbine is connected to another one that crams more air into the engine's cylinders. More air means you can burn more fuel, and more fuel means a bigger boom and more power. It's a brilliant way to recycle wasted energy. Now, all that power needs to be managed. That's where the transmission comes in. Think of it like the gears on a bicycle. When you start from a stop, you need a low gear for lots of torque to get moving. Cue. Once you're cruising on the highway, you shift to a higher gear to keep the engine relaxed and efficient. Whether it's an automatic that does the shifting for you, or a manual you control with a clutch, the transmission S job is to make sure the right amount of power gets to the wheels at the right time. Of course, going fast is fun, but stopping is crucial. That's the job of your brakes. And most modern cars have anti-lock braking systems, or ABS. Have you ever slammed on the brakes in an old car and felt the wheels lock up and skid? ABS prevents that. It uses sensors to detect if a wheel is about to lock. If it is, the system rapidly pulses the brake pressure on that wheel, hundreds of times per second. This allows the wheel to keep spinning just enough to maintain steering control, letting you steer around an obstacle while braking hard. It's a true lifesaver. Speaking of lifesavers, let's talk about airbags. How do they know when to deploy? It's all about deceleration. Your car has sensors, called accelerometers, that measure how quickly it's slowing down. In a normal stop, you decelerate gradually. But in a crash, the deceleration is incredibly abrupt. When the sensor detects a deceleration severe enough to be a collision, it sends a signal. This signal triggers a chemical reaction inside the airbag module, instantly producing a large volume of harmless nitrogen gas, bisq. Gas inflates the bag in a fraction of a second, creating a cushion to protect you from hitting the hard surfaces of the car's interior. It inflates and deflates in the blink of an eye, but the future is electric. So, how do electric vehicles, or EVs, work? It's beautifully simple. Instead of an engine, you have a large battery pack and one or more electric motors. When you press the accelerator, the battery sends electricity to the motor. The motor uses electromagnetism to create rotation, spinning the wheels directly. There's no complex engine, no transmission in the traditional sense, no exhaust. It's quiet, efficient, and delivers instant torque for that thrilling acceleration EVs are known for. And when you brake, many EVs use regenerative braking, where the motor acts like a generator, converting your car's momentum back into electricity to recharge the battery. So, from the controlled explosions in an engine to the silent, instant power of an EV motor, your car is a marvel of science and engineering. It's a collection of brilliant ideas working together to make your life easier and more mobile. Next time you get behind the wheel, you'll know exactly what's happening. Thanks for watching. If you enjoyed this breakdown, hit that like button and subscribe for more simple explanations of complex tech. See you in the next one.